Hello, science students. Welcome to another review video for the scientific method. Today, we will focus on the procedure, data table, and creating a graph. First things first, remember that the scientific method is a set of steps that helps to design and carry out a repeatable, testable experiment. We've already gone over the question, variables, and prediction or hypothesis. Today, we're going to focus on the procedure, data tables, and graphing. Procedures are a detailed set of steps. They need to be very, very specific so that someone else can carry out the exact same experiment in the exact same way and hopefully get the exact same data or patterns or trends. To help accomplish this, it needs to include the names of tools or materials that are used, as well as detailed amounts of items. Instead of just saying, pour the water into a beaker, a really good procedure step would be pour 50 milliliters of water into the 250 milliliter beaker. That helps someone carry it out exactly the same way. And when experiments are repeatable, and the data ends up the same every time, you start to have a very large, well-supported body of evidence to support your conclusion. Let's take a look at an example procedure. This experiment wants to compare different types of batteries and see how long they will work or how long their charge lasts. First of all, they tell you to number the batteries so that you can tell them apart. When you have several batteries in your tests, you would hate to test the same battery twice. It would really mess up your data. Number 2 tells you to measure the starting voltage using the voltmeter, and then put the battery into the flashlight and turn it on. They let this run for 5 minutes before measuring the voltage and record it in the data table. Notice that their procedure includes the name of the data table. Sometimes you'll have multiple data tables in an experiment. Maybe they have another section that they'll complete where they use one type of battery in different devices. And so there might be a data table number 2, devices versus battery charge. The directions go on to tell you to repeat number 4, collecting a voltage reading every 5 minutes until it's below a certain value or the flashlight stops working. It reminds you that you need to do these steps over and over again until you have 3 trials for each brand of battery. So you do Duracell test number 1, Duracell test number 2, Duracell test number 3, Energizer 1, 2, 3, Amazon 1, 2, 3, so on and so on. Those steps are detailed. They have specific values, specific names, and should be repeatable by someone else. Once you have that procedure and you begin collecting your data, you want to have a place to record it or write it down as it's coming in. If you're making a measurement every 5 minutes, or sometimes even quicker, every 30 seconds, you need to have a spot to write down your value so that you can make your measurement and record it in a very short time frame. To do this, you want to set up your data table ahead of time. You need to include a descriptive title. And if you have a really good title, that data table title might work for your graph later on as well. You need to label the tops of each column, and that's usually the independent variable. You need to label each row along the side, and that's usually the dependent variable. You need to make sure to include units of measurement as well. If you're measuring time somewhere, you wouldn't just say time number 1, time number 2, time number 3. You'd actually include the amount of time that was occurring in between each measurement. Maybe 30 seconds, 60 seconds, 1 minute and 30 seconds. And so you would have an actual value there as opposed to just trial 1 or time 1. Let's take a look at an example from earlier, from presentation number 1. One of our examples was this question: how does the amount of sunlight affect the height of a plant? Remember, you want to label things about your amount of sunlight or independent variable above the columns, and things about the dependent variable along the rows. Let's take a look at what this might look like in a completed labeled data table. Notice there is a title, weekly plant height versus sunlight. You can see we have the independent values, the amounts of sunlight labeled along the top, and then the measurements for plant height labeled along the left side. Another example, type of deodorant and body odor. Think about what types of deodorant could be tested, what might the body odor measurements be, and you could fill it in with something like this. Notice again you have a good descriptive title, effectiveness of clinical and regular strength deodorant, so it lets you know we're looking at how well they actually work. You can see that we've got a control unit in no deodorant and what that would smell like, clinical strength, and then regular strength. And we've got 3 different test subjects who are going to use the different types of deodorants and allow us to smell their body odor. In the third example, amount of sleep and grades, pause the video and try to set up a data table on your own. Did it look something like this? Your values might be different, but they should relate back to the amount of sleep. Here I thought 6, 8, and 10 hours of sleep might be good numbers. People hear that 8 hours of sleep should be the average, and so what would it be like if it was a little bit more or a little bit less? And then here we've got different students who will do tests so that we have more than one set of data. Once you have collected all of your values and recorded them in the data table, you want to turn it into a graph. This helps you easily identify key pieces of information or trends. It's much easier to pick out the largest value in your graph than it is to pick out the largest value from the data table. Depending on what type of data you're collecting and the way that you're conducting your experiment, you could use a different type of graph. Bar graphs are really good at comparing one item to another. The deodorant example might use a bar graph so that you could look at how no deodorant performed on the sniff test, the clinical or extra strength, and then the regular strength performed. And you could look at the differences between those items very easily. Line graphs and double line graphs are used when time is the independent variable. If you're measuring changes over time, you want to use a line graph. Line graphs are very, very good at showing those changes in a value, specifically when the changes are very small. If you have some very large changes in time or in your measurement, using a bar graph could be helpful for that one. But generally, whenever you're talking about time, you want to use a line graph unless you have very, very, very large changes in your values that you're recording. Double line graphs are just like a line graph, but they've got 2 pieces of information over that same period of time. And then we have a scatter plot and best fit. These are used when you have very, 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 very large data sets. When we're talking about thousands and thousands of tests or hundreds of tests, scatter plots and best fit are really, really useful. It helps to identify a pattern when it may not be super obvious what the trend is amongst all of these lots of different data points. Let's take a look at an example of each one. Regardless of which one we're looking at, all of them contain the same thing. They need to have a good descriptive title, and we talked about how you could probably use the same one from your data table. The independent variable should be on the x-axis or the horizontal, side to side. The dependent variable should be labeled with your units of measurement on the vertical or y-axis, up and down. And then there should be a consistent scale that starts at 0 next to your dependent variable on the y-axis. This helps us read the information and know the values within the graph. And then it needs to be spread out so we can easily read the graph, smushing everything to the left or really, really low on your scale doesn't really work. You want to take up the majority of the space in your area, and you want to have equal increments between items. You wouldn't want to put your first 5 minutes of data spaced 1 minute apart, and then your next 5 minutes of data spaced 1 second apart. Those would be very, very, very misleading graphs. And then, of course, you need to make sure that you have it graphed accurately. Let's take a look at those examples I talked about. In general, you'll find that descriptive title at top. You'll find that dependent variable and units of measurement here on the left. You'll have your scale on the left going vertically as well along that y-axis. You'll have your independent variable here along the bottom of your x-axis. Another bar graph may look like this. Here you can compare the number of student birthdays in January to June very easily. You can quickly pick out the most common months for birthdays and the least common months for birthdays. You can also see which ones have the same number of birthdays very, very easily. Line graphs and double line graphs are really helpful for looking at trends. For instance, you could look at this yearly attendance at Mesa Verde National Park and see that over the past 10 years, attendance has stayed relatively the same. There was a little bit of a dip for a couple of years, and there were a couple of years where it was up, but generally speaking, it's stayed at about the same level. Double line graphs, you can see how two different things are changing over the same time. And so you can see that here in Denver, we generally have the same range between high and low temperatures throughout the year. So the difference between the low and the high value is very similar throughout the whole year. It gets warmer in the summer, but the coldest values, the coldest temperatures are also about equally warm compared to the rest of the year. Scatter plots and best fits. These are used when you are looking at very, 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 very large sets of data. This is when you're talking about like hundreds or thousands of pieces of information, and you're really trying to look for a trend or a pattern amongst it. It may not be very obvious as you look at these individual points what the general pattern is. But using some statistical analysis and the help of some computer programs, you can very easily enter in a data set and then have a calculation of the line that best fits these values. In this example, which I would like to remind you I made up, it's not real, but this is the type of thing where it would be used at, as you're trying to evaluate maybe whether a medical treatment or a drug actually helps someone feel better and make them recover quicker. So in this instance, you can see that there's a large amount of individuals who have different ages, and then how long it took them to recover after they first got a treatment or a medicine. You can see that in general, as the age went up, it took them longer to recover, regardless of getting that. But where this comes in handy is in a large like medical study, they compare it to people who did not get the treatment. So they got given a sugar pill or something that was fake, no actual medicine in it, and this was the best fit of their recovery time. It's really helpful in this instance to be able to look at these two and say, yes, this particular drug or treatment actually did lower the amount of time versus people who did not get the drug. In my example here, I've only got about 35 different data points. That would be a really, 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 really small medical study. That would be very, very, very early on when someone would say, hey, I think there's an actual pattern here, and I think this might actually help. And then it would go to large-scale testing where you've got thousands of individuals. They look at the effects on not only age groups, but possibly gender, maybe people with other medical conditions like diabetes or heart disease, and see what happens with the drug and their recovery rates. And it takes a long amount of time to gather enough information to say, yes, this is really, really leading to the change that we think it is. I hope that this helps you better understand how to write a procedure, create a data table, and make a graph.